Now let's analyze sorting algorithms. Let's start with bubble sort. Before we continue, make sure that you review bubble sort and how it works. Here's our code for bubble sort. Now, which parts determine its running time? Obviously, the operations that will determine its running time are the conditional and the swap operation. We'll assume that they both run in constant time. But as we have determined earlier, and will again prove soon, comparisons are more important, and for bubble sort's case, they occur more often. Worst case for bubble sort. Again, the worst case happens when the maximum amount of code is executed. For bubble sort, that means when the array is reverse sorted. With that kind of input, these lines will always execute. So we simply have to count the number of times these execute. The outer loop iterates n-1 times, and the inner loop executes n-1 minus I times. We can express that using a summation. The summation of n-1 minus I, where I goes from 0 to n-2. Take note that 0 to n-2 is n-1 times. To simplify, we could separate the summations, then simplify both summations. For the first one, we have n-1 number of n-1s. Then the second one is just an arithmetic series. Again, the first one is n-1 number of n-1s, and the second one is just an arithmetic series. So if we simplify, it'll be like this. Then let's further simplify. We'll get this, then this. You can review this on your own. I'm pretty sure it's correct. And finally, we'll get n times n-1 over 2, or simply O of n squared. So bubble sort's worst case is O of n squared. Best case. You might think that the best case scenario for bubble sort is when the array is sorted already, and that'll be technically right. If we use a sorted array as input, what would be the behavior of these operations? There will be no swaps, but there will still be the same number of comparisons. This will be similar to the average case. The number of comparisons is still the same, but the number of swaps is variable. Regardless, comparisons will always occur. And since comparisons always occur, like in the best case and the worst case, we'll also get n times n-1 over 2, or O of n squared. So the best and average case for bubble sort is still O of n squared.